Right. So let's look at data visualization. Yeah. So today our topic we will look into what is data visualization, why we want to do data visualization, yeah, and how do we create a good visualization for science, yeah, and what are the different types of visualization scientists, or I would say earth scientists, not just oceanographer, but also those who study atmosphere, like meteorologists, how they prepare visualization for their data. Yeah. All right. So data visualization is an important part of science. All right. So the reason is that it allows us to examine our data. Okay. So let's say if you collected some data, and if you don't visualize it, you don't know what the problem is there. Yeah. Let's say you try to record some parameter. Example, I would say, let's say rainfall. Yeah. You collect the rainfall data. Okay. And you just collect. Yeah? Every minute you collect the rainfall data. You use instrument, obviously. You collect a minute, every minute's rainfall. Okay. And sometimes the instrument maybe in between of the collection, it might have some problem, right? So sometimes it might read the data as negative value. Okay, but if you don't visualize your data, okay, you just use the data as it is to calculate, let's say, any statistics, to calculate, let's say, the mean, the maximum, or the minimum, you will get very problematic result. Imagine having a negative rainfall, something that is actually impossible. Because rainfall is just like measuring the amount of water. So can your amount of water be negative? Obviously not, yeah? So if you don't visualize your data, you don't know. And you use the data to do calculation or anything. Okay, so eventually you will get a very wrong result. So that's why whenever you get a data, let's say you are collecting data, no matter you use the primary or secondary method, you get the data and you don't plot it out. The plot it out here, you can just plot, let's say, a simple let's say a graph, yeah, for, let's say, if your data is 1D, one dimension, or you plot a map if your data is 2 dimension, meaning you have a long and length. Yeah, if you didn't plot it out, you might not know your data has problem. But if you plot it out, you will know. Okay. So the next reason we want to do data visualization is it enables us to be aware what our data is trying to tell us. Yeah. So if you plot the data out, because you keep collecting data, example, you're collecting data for a year, yeah, you just collect the data. You cannot see anything. Yeah? Because let's say we try to study the climatology or the annual cycle of rainfall. If you just collect, yeah, because day to day changes, maybe not that much, right? It rain, no rain, rain, no rain. So you actually don't know what is actually happening. All right. But if you plot the data out, you can see. Yeah? Example, you plot the graph, you can see, okay, during December, the rainfall is very high. Yeah. During August, the rainfall is very low. So you can see pattern like this. So you are aware, yeah, the situation that is actually happening based on data. All right. And the third reason, or the main reason we want to visualize our data is we want to convey our messages. Let's say I want to tell you something. So I show a picture, I draw a picture, right? So people always say a picture worth 1,000 words. All right. So if I can tell you many things for a very, very long time, but you cannot understand what I'm talking about. But if I show you one picture, you will know. Right? So it helps us to convey messages, yeah? And producing nice looking, neat, and intuitive graphic is utmost important. Okay, your graphic need to look nice, look neat, and intuitive, meaning when you just look at the figure, you know what the figure is trying to tell you. All right, so you can look at the example below. Yeah? I have two graphic, A and B. Yeah, like I say, picture worth 1,000 words. So the question, right? Graphic A and B, it depicts the same character in a certain popular game, right? So between A and B, which one you think is more pleasing to your eye? So you have a character A, yeah, it's very boxy, very, look a lot of polygon, you can see polygon. But the B one, you see, the hair is so smooth, yeah? The facial expression is like so real. So which one you feel pleasant to your eye, right? I mean, of course, choice is very personal. So no matter which one you choose, A or B, right? So I bet most people will choose B, right? Because you're a young generation, you don't have this nostalgic feeling towards this character. So I bet most likely of you choose B, because you look at the figure, it looks clean, it looks nice, right? And it looks neat. Okay, of course, intuitively, it's just two characters, and both also intuitive. But that's why you can see the power of producing nice looking and neat graphic. Yeah. So no matter which one you choose, A or B, which one you like, up to you. When you create your figure or you create your graphic, you have to ask yourself, is the graphic you created pleasing to your own eye? Yeah, do you like what you created? Or we just don't want to plot it. Okay, my lecturer asked me to do this, so I plot it out. So we don't want that. When you plot your figure, ask yourself, is your figure looking nice? You feel your figure look nice? And can you easily understand what you have created at your first glance? If you just look at the figure you plotted, you ask yourself, can you understand what you have plotted? All right. So these are the few tips that you have to remember when creating a nice looking figure. All right. So let's go to the next one. Okay. So here we have an example, example of a very untidy data visualization. Okay. So we can see from here, there are 4 different plots. Okay. But you can see the size, they are different. They are not arranged neatly, right? So when you look at this figure, you feel it's very unpleasant. It's very not nice looking, very ugly. Okay, so here only have 4 panels. Probably it's fine, but sometimes if your figure is very untidy and you have a lot of figure, it can make it very hard to read. Okay, so the same thing. Let's say people, scientists have to publish scientific article. Students have to submit thesis. So when you submit this type of document, there are people who will review or read your work. If you don't have a very nice looking figure or easily to read figure, most likely you get a very, let's say, a bad score for your thesis. Or if you publish paper, you submit paper to journal, they might reject your paper. Yeah, because it's so difficult to read. Yeah, people don't want to spend much time, to understand what your figure is about. Okay, so remember, neat figure, easily understandable, and nice looking figure is very important. The same for science. Okay, then after you create a nice looking, neat looking, and intuitive figure. So the next very important thing is called labeling. You need to label your figure well. Yeah. So when creating a data visualization, use proper label. Okay. So the reason we use proper label is it will help us to understand and interpret our diagram correctly. Okay. Of course, the label you use must be clear and correct. All right. So let's look at the example below. Yeah, one is with label, another is without label. You already saw this graph in your mid-semester exam, but they are basically the same graph. So let's assume you haven't seen this graph with proper label. If I just give you this one, this line, some of you might thought it's actually a distribution graph, right? If you didn't label properly, you just see, okay, you have this very minimum, that go to a peak, then you go down again, right? It looks like the skewed to the left distribution graph, right? But actually it's not. If you label properly, you will see, okay, this value is actually microgram per meter cube, and you have a time at the axis. Yeah. So this tell you this is actually observation data. Observation data of something with mass in per volume. This is actually PM10, particulate matter with 10 microgram, 10 micron, sorry. Yeah, not 10 microgram, 10 micron, meaning the size is 10 micrometer. Okay, so you can see graph like this. I mean, when you have a label, so when you see graph like this, you know, okay, this graph actually tells you the observational data. It's not distribution. Okay, if you don't label, you can imagine anything you want. Yeah, you might be very far away from the real truth of your diagram. So always use proper label when you want to when you present your figure. Okay, and remember, sometimes you prepare a figure, it look nice to you, right? You prepare on your computer, it looks nice, everything look clear. But if you put in PowerPoint, you have to ask yourself, is now the label clear, right? Sometimes it looks clear to you, but when you put in the PowerPoint, yeah, your graph is being, let's say, the graph will become smaller lah. Okay, so when it becomes smaller, the label might not be clear anymore. Okay, so in that situation, you might want to replot your figure with a larger label. Okay, so always adjust the label on your diagram based on the medium you are going to present. Okay, whether in a PPT, Microsoft Word, or I don't know, any or maybe you want to put in a Facebook or anything. Yeah, so make sure the label is readable on that medium. Okay. Next, so this is another example, the importance of labeling. So two same figures with maps. Okay, so obviously on the left is the figure without labeling. On the right is the one with labeling. Okay, so let's look at on the left, right? So when you first look at it, you have no labels. You don't know what is the meaning of the first panel, second panel, third panel. What are those? You don't know. You can just see it's a very colorful picture, right? Even then, you don't know what is actually the color mean. Then the blue color, what does it mean? Yeah, the greenish, pale greenish blue, what does it mean? Right? We don't know. Right? Just like you look at those abstract art. Yeah, you don't know what the artist is trying to tell you because obviously those art don't have label, right? So the same thing for science, right? We are not trying to create abstract art. Yeah? We are trying to create something to convey messages. All right, so we need to label them properly. So you can see on the right side. So right, so we label it nicely. Okay, so we know the first panel refers to January, second panel refers to February, March, April, and so on, right? And of course, I included a color bar. Yeah, so this color bar gives you an idea what does the color mean, right? So when you look at this very blackish blue, yeah, you will know it recorded the rainfall more than 24 mm per day, 8 meter per day, right? So when you see something close to white or this greenish blue, pale greenish blue, yeah, so you know the rainfall is maybe more than 0.5, but less than 1 mm per day. Okay, so this is the importance of doing labeling, yeah? So another example is this one. So I bet, I'm not sure how familiar you are with this, considering you haven't worked with your PITA. Yeah. So this diagram show you location of sampling point. Yeah. You don't know. I tell you, so you know it's actually sampling point, right? Because you don't have any label. So can you tell where this location is? Do anyone know where is this location? If I just show you this, obviously you can't. You don't know, right? You don't know where is this green thing is. This is actually Langkawi Island. Yeah? So you see a red dot. So what does this red dot mean? Okay, I tell you it's a sampling station. You know red dot obviously should mean sampling point. But which is station number 1, station number 2, station number 3? You don't know, right? Because we don't have, we don't, I mean, the people who produce this map does not label anything. And what is the orientation of this map? Yeah, so the vertical going up is north, south, east, west. We don't know, right? And of course, what does the green color mean? Blue. What's the blue color mean? And what does the red color mean? We don't know because there are no labeling. So the improvement you can make is first label the map. Yeah, let's say we don't know where is this location. You can label it with longitude and latitude. Okay, I hope you know what is longitude and latitude. So label it with longitude, latitude, because from longitude, latitude, we can know where you are. Yeah, or we can know where this island is. Or even better, you can provide another small map, let's say a Malaysia map, and you box it out. Where is this location? You draw a box. Let's say over Langkawi area. You draw a box. You tell them, okay, this box area is the study area. Okay, and this map is the study area, but showing sampling point. So, but for the bare minimum, you label it with longitude, latitude. Okay, because if people want to know, they Google it up, Google up the longitude, latitude, they will know where it is. Yeah. Next, of course, we want to know which station, which red dot correspond to which station, right? So obviously label it. This is S1, S2, S3, S4 for station 1, station 2, station 3, right? So label it. Okay, so people know, okay, let's say you presented something regarding to station 3, so people can check where is actually station 3, or maybe it's at this bay, station 3, or maybe station 3 exposed to this open water. Yeah, so you need to label it correctly. And to want to know what is the orientation of the map, you can add in a north arrow. Yeah, but we have to remember, not always we need a north arrow. Obviously, if you show a map of Malaysia, peninsular Malaysia, and if the orientation is north upward, southward, you don't really need to have a north arrow. Okay, north arrow is important when you don't know the orientation of the map. The map can be like in any orientation, but you want to tell the people, okay, this is north. Then you include north arrow. So for here, obviously, yeah, probably it's okay to include north arrow because, right, if I just present you with this map, you don't know where the orientation is. Okay, because people are not familiar with Langkawi Island, the shape of Langkawi Island. All right. And of course, lastly, we can include a legend explaining what is green. Let's say green, land, blue, ocean, red, sampling point, example. Okay, so you have a proper labeling so people know. Okay, and sometimes if you want it to be fancy, you can include also scale bar. Okay, like 1 cm on paper is equivalent to how many kilometer on the real world, something like that. Yeah, scale bar. Okay, so we talk about labeling, the importance of labeling. So the next important thing is data range. Now assuming we are plotting for your data. So when creating a data visualization, we have to make sure the range that we use, yeah, for our figure for our visualization, it must be sufficiently cover your whole data. Okay, so you can see example one. So this is also rainfall data. Yeah, let's say if you have a rainfall data like this one, and you use the range of 5 and 10, minimum 5 mm per day, maximum 10 mm per day. So you can see you have a figure like this. You can't even read what is the pattern it is showing. You just see a lot of line going here and there. You don't know what these lines are, right? But if you use a proper range, let's say 0 to 20, you can see there's some fluctuation. Yeah. And if you know how to read, you see sometimes the rainfall go up, sometimes it go down, up and down. Yeah, from year to year differences. So we can see pattern like this. We can know what is the data is trying to tell us, right? If we use proper data range, yeah? But not always. Sometimes we really need to use the full minimum maximum, depend on cases. But most of the time, you want your data, the that you use slightly larger than the maximum, slightly smaller than the minimum. Yeah, so that you can see the full clear pattern. But this sometimes can depend on from cases to sometimes it can be different for different cases. But most of the time, it will be like that. Okay. So the next example you can see. So we see the graph. So the second example is the map, contour map. Okay. So example number 2 also show the same information. So precipitation rainfall for January. Okay. You can see from figure this on the left and on the right. Okay, so the difference between left and right is actually the range of the data range we use to plot our data. You can see 0 to 6 and 0 to 12. Yeah, so on the left side, you can see they have very large patches of this pink color. Right? Pink color signifies the rainfall more than 6 mm per day. So if you plot something like this, you only get whole patch of pink color. A big patch of pink color showing something here. Which means signifying the rainfall is very high, more than 6 mm per day here. But if you use significant range, you use a proper range, so you can see there it actually shows differences, small differences. It's over Terengganu, over Pahang, over Johor. Johor have a higher rainfall compared to this in between Johor and Terengganu. But if you plot without sufficient range, you can see only one patch of pink color. So you cannot see these small differences hidden in the data. Okay, so this is also the reason why you will want to have proper data range, so that you can see those small differences which might be hidden away if you use the wrong scale. All right, so I hope you are clear on this. Next, let's say when you are creating a comparison diagram. So for here, you want to compare the rainfall between different season. For first one is December to February, then March to May, June to August, and lastly September to November. Let's say you want to create something like this to compare between the 4 panel. So it is important for us to use standardized scale in this case. All right. So the reason is why you can see on the left side, the figure is plotted with non-standardized scale, and the right side is plotted with standardized scale. So let's look at the non-standardized scale first. So non-standardized scale here means different month or different season, it has its own color bar or has its own data range or color range. All right. So you can see this one is 0 to 13, 0 to 13, 0 to 13. This is 2 to 13, 2 to 13, 2 to 13, and this is 6 to 16. Not standardized, right? So okay, you see those standardized ones, you can see there are actually clear differences, right? But for SON, the one without standardized scale, you can also see differences between them. So if you, on the first glance, you look at this figure, right? Just look, okay, sekali pandang, like this. Just look at it. So you will think that during December, January, February, we have a very high rainfall in Malaysia, Peninsular Malaysia. So you will tend to say, right? December, January, February is the rainy season for Peninsular Malaysia, whereby the rainfall is the highest. For all the months. In all the months, all the season among all the season, it is the highest. Right? Because obviously you see you have green color, red color. This one green color, blue color, a little bit red color, but still lesser than this one, and a lot of blue color, and this one is blue all the way. Right? So you will tend to have this impression that December, January, February, you have the highest rainfall for Peninsular Malaysia. But let's say if you look at this right panel, right diagram, where we use standardized scale. Okay, so now we use 0 to 12 for everyone, right? So can you now tell which one actually have the highest rainfall? Where is actually our rainy season, right? So obviously you look at it, you know it's actually September, October, November, right? So the reason why you have so much difference between standardized scale and non-standardized scale is, you see, it's because when standardized scale, you scale the data, the color based on your data, right? So if when you do scaling like this, so some high value might have a very different color for different season. But once you standardize them, so everyone will have the same color. So the only change is in the data. Right, so we can now see very clearly. So the rainy season for Peninsular Malaysia is actually September, October, November. Only for the East Coast is over December, January, February. Right, so we can see very clearly the differences like this. All right, when you use the standardized scale. So remember, when you are doing diagram for comparison, let's say you are plotting 4 or 5 or 12 different month of something, let's say sea surface temperature, yeah, or even anything, use standardized scale. Yeah? Use standardized scale lah, if you want to do comparison, because if you don't, some signal might be hidden and it might give you a very wrong conclusion. Yeah, just like this example. Right? Okay, then another one, when we talk about data range, is what we call log scale. Log scale. So in some situation, when you plot a graph or something, or a graph, I would say, you might need to use log scale. Because I don't know if you are aware, I mean, supposedly this you already learned during your secondary school. Yeah, in some situation, when you plot a graph, if you have a linear scale, it might not work. It might not show you what the data is actually trying to tell you. So in this situation, you use log scale. So let's go to this example. Yeah. So let's say you have a linear scale of graph. Yeah. Let's say your data is you plotted your data in the linear scale. All right, and you have a data spread linearly. So when you plot it, you get one straight line. So meaning all data is well represented by the scale. But in some situation, you have data like this. Yeah, you can see the distribution is very the distribution data is very dense over a very small scale. I mean, small range, I would say, over a very small range. Yeah, but there are some data spread very far apart. Yeah, so if you plot it with a linear scale, this is what you get. Yeah, for data spread linearly, you get straight line. But for data that are not linearly, you get something cluttered here and it's spread out. Yeah, so this makes visualization difficult. Okay, this usually log scale is rarely you use unless you are working with, let's say, vertical, in our field, unless you are working with a vertical profile, then most likely sometimes you will need to use log scale. So example, now this is the example for linear scale. If you change the log scale, so the array, those data is spread linearly, it will become like this. But the original underrepresented diagram or misrepresented data will now show one straight line, meaning the data is well represented for every point. Yeah, so this is what happened to your graph. You can just go through this one, and I'm going to tell you. We are not going to discuss this further. So basically, what happened if you use a linear scale and a log scale? How the visualization change? Yeah, so you just go through this one. Okay, next is called what we call standardization and normalization. Okay, this is some statistical technique lah. Normalization. Normalization, usually you make your data 0 to 1. Standardization, you actually make your data fluctuate between around the 0. Yeah. So why you want to do that? Okay. So sometimes standardization or normalization of data we need to conduct it before create our visualization. Yeah. For example, if we are trying to compare the fluctuation of two parameters with different magnitude, yeah, like this one, like this example, yeah. So let's say we have this blue line, the blue parameter, and we have this red parameter. You can see they have a very different magnitude. So if you didn't standardize them, you plot it out, you get the blue line fluctuate very large, right? It fluctuate a lot, very strong fluctuation in or oscillation. So the variability is very, very large. If you calculate the standard deviation variant, it will be very large. But if you didn't standardize this one, the red one, you see, it only fluctuate at a very small range. Let's say 30 to 60. Yeah, but the blue line is 90 to 300. So you get an impression like this if you don't do a standardization. So let's say if you do a standardization here, yeah, so now my value fluctuate in this 0 line. So you can see the variability of the data, or the variance of the data actually comparable. They're actually comparable if we standardize our data and make us able to compare between blue and red. If not, if you didn't standardize, you can see blue fluctuate a lot. Red may be just one straight line. You don't know how different they are or how similar they are. But if you do a standardization, yeah, you can see them actually. Their fluctuation you see in this case actually comparable. Of course, the blue one is still slightly stronger, but you can compare them now. Okay. So what if you don't want to do standardization? Yeah, what if you don't want to do standardization and you still want to compare between two variable? So you can use the method by plotting multiple axes for your figure. Yeah. So if you don't want to do standardization, you can plot your figure. You plot a graph like this one, but you have multiple axes. Yeah. So for this example, I have multiple y-axis. Yeah. So the red one corresponding to the red data, the blue one correspond to the blue data. Okay. So now you can see they actually kind of comparable. Yeah? And this one also the same. Okay. So this is the different way you can work with, display your data lah. But when you use a multiple axis approach, you have to be very careful. So you can see from this diagram, this look a bit cluttered. It has 1, 2, 3, 3 y-axis. Okay, so when you do something like this, so it look very cluttered, right? You need to see like, okay, temperature. Which one is actually temperature? So when you look at this black dot, yeah, you want to look at the scale, so you have to go here, right? But when you want to look at wind speed, the wind speed is the star, so you have to look over. That you have to skip like one axis, two axis, and go to the third axis. Then only you know, okay, this is how wind speed looks like. Okay, so it can be very cluttered when you try to plot your data with multiple axis. Yeah? And actually, I don't really recommend you use this, but depend on situation. Yeah, but if you really want to compare between two parameters, it's always best you do standardization. Okay, because standardization will show you clearly actually like this one. The blue have a stronger variation than the red. But if you plot with different axes, you might not see that. Okay. Okay, next we have to avoid overcrowding when you prepare your diagram. You have to avoid overcrowding, meaning you have too many figures in one page. Yeah, so for example, you can see from here, let's assume you don't see the color. Yeah, everything is just black and white. So you can see from here, there are 20 line graph. This is actually endocycle 20 line graph. Yeah, with around 19 lines for each graph. So let's imagine it's grayscale. So it will be very hard to read. Okay, because there are too many information in one place. It makes you hard to read the diagram. Okay, so you have to always, if you can, avoid overcrowding your figure lah. Okay, but if you cannot avoid it, you have to think of a way to make your figure readable. In this situation, different types of line were used and different marker were used and also color. Yeah, so of course when you use color, in this situation, I actually the one plotting this one. So we don't simply use colors, don't simply use marker, and don't simply use line type. Okay, if not, you will also create a very messy graph, even you use different color, different marker, and different line style. So let's look at this example. So the red one, the red, orange, yellow, green, blue, yellow, something like that, purple, yeah, they actually have a meaning. Yeah, so when you see the line is red color, you can see they are actually using the same setting for this GRELL. I don't care what it is, but this is just a setting, right? So they use the same setting like this one. Orange is MIT, MIT, MIT. Yellow is MIT plus Grail, like this. The green one is all Grail. And the blue one is all Grail AS, and purple one is called Core. Example, this one. When you use the same we use the same color for the one with the first setting having the same first setting. So next we look at the solid line. Yeah. So you can see all solid line. The setting number 2 is called BATS 1E. Yeah? So they use the same setting. Okay. So actually the solid line and the marker as well. All right. So by doing this, yeah, it's still difficult to read the diagram, but most likely you can see if they use this setting, so where the graph will be. Okay. While you still have a lot of information, this somewhat helps helps to make you see clearly the information you want to look at. Okay. So we have to find a way. Let's say if you cannot avoid overcrowding, think of a way to make your figure can be easily readable. Okay, because when you plot something, you want to convey messages. Okay, so you want the receiving party to know what you are talking about. Okay, so that's why you have to always find a way to make your diagram readable. Okay. Okay, next, this is very important. Color scheme. So we have to, when we do something, when we plot our figure, when we create visualization, it's always important for us to use proper colors. Yeah. So usually when I see student plot figure maps, so they will just simply use any color available, or the color come with the software. I mean the default color comes with the software. But sometimes we don't want that. For example, you can see from here. Moment. Okay, nothing. So you can see from here. So you have a figure A. Yeah, you have the earth, picture of the earth, picture of a lady, and a picture of an apple. Yeah, black and white. So your task now is to paint the figure with colors. Yeah, so you know this is your data. So you want to paint colors. So let's see number 1, color scheme jet. Jet. So color scheme jet is a bit like rainbow color. So you see when you paint the earth picture with jet, the old lady picture with jet, and the apple with jet. So you find it looks weird for the old lady and for the apple, right? It looks very weird, right? Because it seems like you see you have a lot of red here. It's like, you know, it looks like a panda, a panda with color panda. It looks like a panda for this old lady. But if you use this backglow scheme, this scheme, you can see the lady looks okay. The apple also look okay. Look natural to your eye. And probably not the earth, right? But if you use jet for the earth, probably okay because you want to highlight something. Okay, so you see from here, depending on different situation, you might want to use different color scheme. You don't always want to go with the default one or with the one and only one you use. Okay, you have to depend on your data. Let's say you're trying to paint the picture of a human, the picture of an apple, you are not obviously not going to use jet, but you use another color scheme like backglow instead, so that the picture looks pleasant to your eye. Yeah. So when choosing color scheme, sometimes depending on our reader, you might want to consider those with color division. Okay, not every one of us able to look at the full set of color. Yeah, I bet maybe some of among you, I don't know, maybe have color division, vision division. Yeah, like this one. Some people only can see 2, 3, colors. So this is what they see. We see this one, but what they see is something like this. Or some people don't even have color vision, color blind, so they can only see grayscale. Yeah, so you have to, depending on your audience. So when you create your map, your visualization, so you have to use the color they can see. If not, let's say if you use jet like this one, and you have black in at the end, both ends of this spectrum, but in the middle you have white color. So you plot it with jet, so you see, okay, some have blue, some have red. But for people with color blind, they can only see black. Like why you have like, black over the left, black over the right. So small value also black, very high value also black, but in the middle is white. right? So the message you want to convey might be misunderstood or misinterpreted by people with fortunate, handicap like this. And so depending on your audience, you might want to consider the color you use when you plot your figure. Next, and we have to remember, like I told you just now, color scheme should not be used casually, because some color scheme might not work well for certain data type. Obviously, like the old lady picture and the earth and the apple, So when you want to paint the color, so you cannot simply use any color scheme you want. Yeah. So example, some value if they change linearly, yeah. If the value increase linearly, like 1, 2, 3, 4, 5, 6 until 10. Yeah. So if you use the wrong color scheme, some value might be underrepresented or overrepresented. For example, if you use jet scheme, you can see jet scheme in the middle, this cyan and this yellow is a very strong color. So if you plot your linear value with this jet color, you can see this is something it will looks like. Yeah, 0 to 1 is a bit underrepresented, but here is strongly represented by this cyan color. Also 6, 7, 8 by this yellow color. So this is something we want to avoid. If not, it gives us an impression, right? The value is not changing linearly. So if you give an impression like this, okay? Because the reason is because, when this dark blue become like this one, the shade become lighter. But green to yellow also same. But when you come to this red color, so it become light, become darker. All right. So it means the scale, the lightness, it changes. The lightness, it changes. So it gets stronger, some get weaker, some get stronger, some get weaker. Yeah. So if you try to plot the number, your linear number, if you try to plot your linear number with this type of color scheme, you will get very wrong impression. Just like the old lady's face, the skin tone change linearly. Of course, if you have a birthmark or something, it might not change linearly. But if you have a normal complexion, like any normal people, so your skin tone change linearly. So if you use a jet color scheme, which not change linearly in terms of its lightness, so you will have a very false impression, of what actually your skin tone looks like. In the situation like just now, the old lady, it looks like a panda, like this one. The forehead is very red color, but the eye is like blue color, right? You have a very ugly or not well represented figure. But you can use something instead. When you have something change linearly, you use some color scheme where the so say color and lightness change linearly as well, uniformly. Okay, like darker getting lighter or lighter getting darker, then the data will be well represented because it also change linearly like your data. Okay. All right. And then based on the data type, we have to choose the appropriate color scheme. Okay, there are so many different color scheme. Which one to use? Obviously, the data is either distributed linearly or not. But there are so many color schemes, not just remove color. So we want to know which one to use. So you need to know how the data in your data is being distributed. Yeah, is it sequential, diverging, multi-sequent, or cyclic? All right. So to help you to understand this different type of data, I give you some example like sequential. Surface temperature will change gradually or varies gradually, like sea surface temperature. Yeah, so sea surface will change gradually. So that is sequential. And diverging. Yeah, diverging meaning your data have two opposite ends. Usually positive, negative, like or temperature colder, warmer than the normal. Okay, or multi-sequential like bathymetry and topography. If you try to plot topography and bathymetry color, you will want to the data is sequential. You will want to use color like this. You will not want to use color like rainbow or maybe sequential. I mean, or this background color or this white blue, white red. You don't want to use that. Okay, if not, you don't know where is the ocean, where is the land. Yeah? And of course, cyclic data is like annual cycle temperature. All right, very rare. Usually, the first three we always encounter in oceanography or even atmospheric sciences. Okay, so depending on different type of data, use different type of color scheme. Yeah, and this one, Bedlow just now already show you, it changed gradually. This one, Roma 10, it also a diverging color. You can see blue and red. The color is diverging. As sequential, you have two different scheme basically. This one, gray, dark grayish become white, greenish become a bit brownish and become white. Okay, so these are multi-sequential color. Okay. All right. Next, when you want to choose the color scheme, it's also important. Depend to choose the color based on the nature of the parameter or the variable you will try to represent. Yeah. For example, when you see blue color, you will feel cold. But when you see warm color, you feel warm. Yeah. So when you try to plot something which depict colder, warmer, you usually use this blue and red scheme. Obviously. So you can see from this example, these are actually the comparison between two temperature data set. Yeah. So when you see blue color, you will know one data set is actually colder over this region, but over the other region is actually warmer. Okay, so you just straight away look at this. You don't even need to look at the scale. You know, blue means cold, red means warm. Yeah, it's very intuitive. Okay, so this is how you choose your color scheme based on the nature of your data. Yeah, so another example you can see from here. Yeah, if your data is about dry or wet, yeah, here is the differences between the precipitation, yeah, dry or wet. So when you look at this cold color or greenish color or bluish color, you will know it looks wet, right? The color feel cold, wet. But when you look at brown color, you know it's warm or dry, right? So when you depict something dry, wet, so you use brown, green, or brown, blue example. Yeah. So based on different nature of the data, choose the color scheme wisely. Yeah. So in case you are not very artistic, you are not very sensitive to color, so there is one very, very good website that will give you suggestion what color to use. So this is the website NCL color. And you can just search in Google NCL color table. So it will give you different color scheme. Yeah, like what situation to use. So usually you can check like this for this meteor Swiss. Yeah? So the color people use for meteorological parameter, or even they have Earth Ocean for oceanography studies. So studies. So what color you should use. Okay, let's say example if you are not very familiar with the color, so you can just look at here. So it will tell you what color to use. Yeah, so we can see from here this multi-sequential color. Yeah, this very dark color become pale, very dark color become pale. Yeah, so diverging color like this one. Yeah, or this one. This is sequential color that change gradually. Okay, so you can always refer this website for suggestion on what color to use. All right, let's go to this quiz. Like I told you in this, we're going to do this quiz. So the picture on the right shows different color scheme used by 6 different students in depicting the differences, the difference in rainfall over peninsular Malaysia between northeast and southwest monsoon. So which color scheme you think best represent these differences? So try to go to this menti.com and use this number and cast your vote. So which color you think? Okay, I will give you maybe, let's say 3 minutes. Go to this, look carefully at this different color scheme. Try to think which color scheme you think is the best to represent these differences in rainfall. Can you try that? Yeah, I already see around 19% try. So I hope everyone can just try while I catch some, drink some water. Just cast your vote. Don't worry, no marks will be deducted. Look carefully before you choose and think. Yeah, you feel the color. Can you feel the energy of the color? Yeah, I look at this color, I feel, it's like this. I look at this color, I feel like this. This is the difference between northeast monsoon and southwest monsoon. You can obviously look at the number as well, yeah, and choose the color you think the best. Yeah, 2 more minutes. So 37 casted the vote. We have 38. So what happened to the other people? Like 24 people, where are they? 23%. Okay. Well, unfortunately, we have only 52 respondents, but we have like 69 students here. So I bet some people just left while they turn on the kulia and left. Maybe I should next time do a spot check of your attendance. Okay, regardless. All right. Can you guess what is the most, I mean, the color, the most popular choice when you look at this? I mean, let me, can you just drag this here? Can you see this graph? So this is your choice. You have chosen, you have chosen that rainbow, supposed to be the best color scheme to represent differences in precipitation, followed by this red and blue, then only brown, then blue and red. Yeah. All right. So I bet most of you are not really artistic in mind, and probably you are not sensitive to color. All right. So when you look at this red color, right? Red color represents hot or something very aggressive. But blue color usually give you a very calm feeling, a very cold feeling, right? And brown color, like I just told you, it give you a dry feeling, right? But when you have blue, greenish, it feel like wet, right? It give you a very wet or cold feeling, correct? Yeah. So when you want to talk about differences in rainfall, the differences in rainfall is dry or wet, right? So obviously, when you look at here, positive number, right? When something minus something, you get positive, it means it's larger. When you get negative, it is smaller, correct? So obviously the choice should be E. Yeah, the best choice should be E, followed by C. Yeah, in case, I mean, usually when people depict rainfall, we want the positive number to be wet because obviously the precipitation is wetter. Yeah? And when negative is drier, you want it to be brown color. Okay, so in some situation, people might use C. Maybe B probably still fine. Yeah, maybe B is still fine. But the common color scheme people use should be brown and blue. Okay, so do you make the right choice? Yeah. Okay. And obviously rainbow tak boleh lah. Yeah. Why? Because rainbow you see, the so when you see the rainbow color for zero, right? At the zero mark, you can see there are two green color. Two green color. So from here, we don't know. Okay, because you see, the zero have two green color, right? So we don't know it is actually higher or okay, okay. If you don't know the rainfall is when you have green color, you don't know it's actually higher or smaller, right? You don't know because positive and negative have the same color, right? So obviously this type of rainbow is not usable. But in some situation, there are certain rainbow color. It just so happened it split the negative to be cold color, but the positive to be warm color. So in that situation, yes, that rainbow workable, but not for this rainbow scheme. Sorry, you cannot see my hand. Not for this rainbow scheme. Okay, because you see zero here, you have green color, you also have green color. Okay, so cannot. Yeah, so this one probably still okay because usually we use the red to represent something strong, blue to represent something weaker. But not a common choice. C, yes, probably I would say a rather popular choice. Yeah, because blue give you a feeling of cold, wet, but uh, red color give you a dry, warm feeling. Yeah, so obviously it's not D. Sorry, you go to choose E. If you look at this, if you choose this color, when I look at it, I will say, is it the rainfall over East Coast colder, wetter than sorry, the rainfall during DJF, is it drier than the JJA? If you just look at this, I don't look at the scale. So it gave us a very, very wrong intuitive, intuitively, we get the wrong idea. Yeah, but E, yes, straight away you can tell. Okay, wet, dry. So we know. Okay, and obviously not F, because F, it changed gradually, and our data is splitted, diverged. So we cannot use this scheme. We cannot use F. Okay, so remember when you create your figure, understand first how your data looks like, how it's supposed to be, the nature of the data. How is it a sequential? Is it a divergent? Or is it a multi-sequential data? Something like that. Okay, before you choose your color. Okay, so thank you for participating in that small event. Okay, let's look at another one. Okay, this is like a second part, second part of the presentation. Obviously, I squeeze everything into one class. All right. So look at this data presentation. So when you work with, let's say, I would say usually it happens a lot when you work with physical data. Remember, physical data does not mean if you study biology, you don't really need to use that. Not really. Let's say if you study, let's say coral or distribution of fish or something, so you might sometimes need to take some physical parameters. Okay, so you will also need to know how to draw figure regarding this physical data. So there are two ways we usually conduct our data. I mean, draw our data. First is scalar, another is vector. So for scalar, the common figure that we draw are profile, section, horizontal map. Horizontal map, which you just see just now. And of course, vectors like rows diagram. I mean, vector is cell, and also arrow or streamline if you want to draw wind. So let's look at one by one. First, if you first let's talk about this profile. So profile you can understand is like how something you can think about like a profile about you. So when you say something profile, the vertical profile of sea surface temperature is doesn't mean like how the temperature looks like vertically. So the profile. So when you say profile, it's like about this temperature. So the temperature have this vertical level. So when we say profile, I mean I already said that a vertical structure of certain parameter, and this parameter it can usually change and vary non-linearly lah. So sometimes, sometimes if it change, it can be changing linearly, and it can also non-linearly. It's just like your neutron diagram, if you still remember. Okay, you can change. I mean, if you change linearly, it means it gradually changes. But if you have non-linear changes, it just means something changes very quickly. If you look at this vertical profile, okay, like this one. So this one change gradually, but this one change very quickly. So when comparing different profile, so you have to use consistent scale. Like I told you just now, you use the same data range. So don't use different data range. And in some cases, you might want to use log scale. You want to use log scale if your data, let's say it changed linearly at first, but then suddenly it changed very quickly. Okay, so that one you want to use log scale. Okay? And in some situation, smoothing might be required. Let's say if your vertical profile keep going left and right, change a lot. Right? So you might want to do smoothing, make it smooth like this. Okay? Well, like this one. This graph is not smooth. Of course, it's a bit smooth, but it's not. You can still see it have a bit pointed area, so it's not smooth. All right. So if let's say you have a lot of this vertical profile, you measure vertical profile. There are so many vertical profile in terms of, let's say, time. You measure, let's say, for consecutively for 1 week, 2 week, you would measure the vertical profile of, let's say, the ocean. Or you measure the vertical profile from point A, I mean, across many points in a transect. So how are you going to represent them? Are you going to plot something like this? Different vertical profile? Obviously not. So you will do something known as section. Okay, so section means you draw contour line or iso line. You can look at this. So let's say you have a different reading. Okay, so you can draw green area with the same reading. You have a point, then you can draw the iso line. Iso line means the line having the same value. Okay, you can draw something like contour. Okay, and if the contour line you see packed together very tightly, it just means that the gradient is very strong, like this one. Okay, so draw contour line. So instead, you can from here you can see they have almost the same value, so you can draw a line. Then you can draw a line, I mean, across the area with the same value. So this gives you iso line, and if you combine, I mean, if you draw a lot of iso line, eventually you'll get a contour. Okay, so if you have multiple across the stretch of distance, so it's called a height depth distance section. If you have a lot of, if you measure a lot of profile across the time, we call it the height depth height. If you measure atmosphere depth, if you measure ocean, time section, and if you have multiple profile across time and space, you usually create something like a 3D or 4D, 3-dimension or 4-dimension. The visualization, okay, to represent all those vertical profile you mentioned. Okay, And when you drop a contour, you have to consider the vertical scale, contour intervals, and pattern. So contour interval means do you want to draw line for every point? Yeah, sometimes maybe you don't really need to draw line for all the point. If you draw too much, yeah, everything will be very cluttered and hard to read. Okay, and you of course need to consider how the pattern looks like. You want it to be smooth, or you want the contour to be like triangular or square. I mean, obviously not possible. I mean, very difficult. I mean, it's almost impossible you get a very pointy contour in real life. So in that situation, you might want to smooth your contour. Yeah, smooth your contour, maybe like a bit like this, curvy. Yeah, make the where's my mouse? Then you make this contour curvy. Okay, and of course color. We already talk about this one in a moment. So hot. Okay, next. Yeah, this is an example of section. Yeah, so you have a lot of vertical profile. So when you draw it, you look something like this. So this line is called iso line. So in this situation, you don't really can see like a circular contour lah. But sometimes you can see that, or like this one. This is a bit like circular. So you can see that they use color and they draw every line of the contour. Okay, but they use color instead. Okay, and when you use color, make sure it makes sense. Like this one, you see, temperature anomaly, meaning difference of the temperature compared to the mean. So the red one, straight away you look at it, you know, okay, it's warmer. Blue is colder. Okay. Yeah, and for this case, yeah, this is a vertical section in the atmosphere. Yeah. Yeah, so you see in this situation, right, you can use rainbow because the zero negative is cold color, the positive is warm color, but it's still rainbow. It looks like rainbow. Okay, so if you look at this, they have if the color is warm, it means something going downward. If it's blue, it means going upward. So you can see you have a pattern like this. You have contour like this. This is called section. And in this section, you have a, let's say you have vertical profile. This is depth, and at different latitude, longitude. Okay, so meaning you have many vertical profile at many different points. All right. So example, this is another example of height and depth time section. Height of depth time section. So rather than having longitude axis, you have time. 2010, 2011, 2012. Then you have this. You can see, yeah, during this time, something go up here, and then it go down again, go up again, go down again. So it's like during, let's say December to let's say February of the next year, there's something going upward, but after that something going downward. So if you show us pattern like this, if you have multiple vertical profile at a, let's say many time or many point on the earth, and you draw a section like this, it gives you information as such. Okay, so this is the importance of drawing a section. Because and for 3D, usually people use to draw topography. Okay. Okay, next is the horizontal map. I bet this is the one you are most familiar with. Yeah, so horizontal map, it depicts information at the horizontal properties at a certain depth or surface. For example, over the surface, over the, let's say 200 hectopascal vertical level, or maybe at 1,000 meter below the sea surface. Yeah, so you draw something horizontal in 2D. Okay, so same as vertical section, the iso line of the interval, we need to consider properly. Okay, so when you draw contour, make sure you don't pack too closely. If not, we don't know what this contour line means. And of course, color. Okay, the color that you use, and of course, okay, never mind. The next one is yeah, of course, a linear or log lah. Okay, this one not really, I mean, as a concern, but sometimes you want to draw something at a log scale. And sometimes this horizontal map, people can be, you can draw it with your hand. Of course, usually we use computer to draw it. Let's say panoply, if you're familiar with the class method, we are basically using a computer to help you to draw horizontal maps. Okay, so even though computer is very helpful when we draw this horizontal map, there are some situations sometimes, people will still want to hand draw the map. I mean, they still want to use their hand to draw maps, especially for weather forecast. So for people who do weather forecast, they usually have to hand draw the map. Okay, the reason is because when they draw the map, they know what is actually happening. Because when computer draw the map for you, computer cannot tell you what is going to happen, and you just look at the map. Oh, it look nice. And you just forget about it. You didn't pay attention to what is actually being shown on the map. And so in that situation, so people who doing weather forecast, usually they are required to draw the map by hand because the length of the scales. These are the example of horizontal map. Okay, so this one is a hand drawn, drawn by hand. This one is computer generated map. Okay, these are example of horizontal map. Okay, and when drawing horizontal map, there's something known as projection. I believe this one you should already learn in your, I don't know, maybe the GIS class or something. Let's just go through again. So when we draw our map, right, we are basically effectively trying to flatten our Earth. Our Earth is actually ellipsoid, not flat. So when we want to draw a map of our Earth, we are basically trying to make a sphere into 2D, which actually impossible. So meaning no matter where I mean, like if you have a box, right, you still can flatten it. You can open up the box. But if you have a sphere, can you try to open it up? Obviously you can't. You cannot open up a sphere and flatten it. There's no way. Okay. So how people draw maps then? So they have to find a point where they can flatten the Earth. So there are three ways. One is called planar, meaning you flatten the Earth from from the pole. Planar. Usually the projection is polar stereographic projection, usually used in polar region. If you conduct study on over Antarctica, Arctic, something, planar is what you want to use. But if you study, let's say anything, physical thing, over this higher latitude, you will use conic, that is on cone. So when you have cone, so we basically flatten our Earth at the high latitude. For those of us who study over the tropical region, so we use something known as cylindrical approach when we flatten our Earth, meaning we flatten our Earth, we make our Earth flatten at the equator. Why this is important? So you can look at the figure here. Let's look at the easy one and the easiest one. Everyone is familiar with Mercator. So this is cylindrical projection, right? So we can see at the equator, everything look nice, squarely, not distorted. But you see over the higher region, over the higher latitude, you can see, these land masses is somehow become larger. It's even larger than the Southeast Asia itself. But actually, when you look at this polar stereographic, it's actually just a very small piece of land. Right? So this type of error is due to the projection we use. We try to flatten our Earth. So because the Earth is spherical in shape, if we flatten it, so some region will be distorted. So depending on the region of your study, so choose correctly the projection you want to use so that the map you produce have the less distortion. So it can better represent the real world. Okay. And of course, remember here, I just want to stress north point is not always important. Only useful when you can identify the orientation of your map. Okay. Next. All right, let's talk about vectors. So probably you are already familiar with these vectors. So remember, a scalar value is represented by a singular numerical value. Example, SST. So 289 means 289. 290 means 290 for SST. But for vector, like Win, having direction. When we say vector, it means something having direction. So when you get the data, it usually represented by 2 or even 3 numerical value. Depending on 2 dimension or 3 dimension or not. So let's look at 2-dimensional value. Let's say we try to draw wind. So wind, aside from wind speed, we also have wind direction. Okay. So to properly draw the wind direction, we need 2 components, the U component and the V component. So you can look at this diagram. Let's look at 0.4, let's say. If we have U component 0.4 and V component 0.4. So when you draw it at this point, at this fixed point, so you draw 0.4 unit. U component, U meaning go east, west. And V component goes south, north, south. Okay, so north component also go 0.4. You draw something like this. So how do you draw the direction? So you just move the V to this area, to the ending point of U. So you just draw 0.4 and you combine you join up the vector. So that this red arrow. So this arrow join up the vector. It gives you the direction. And you look at this. This is a right angle triangle. Right angle triangle. So if you want to calculate the magnitude of the unit of this red line, so use theorem Pythagoras. Okay. Use square root of U squared plus V squared. It will give you the magnitude. Okay. And if you want to get the angle, so you just calculate how what's the angle from the northern region, from this vertical line, north-south line. So this gives you the angle of your wind. Okay, so let's say we have 0.4, 0.4. This is where our wind will be headed. So this one. Let's say you have 0.1 and 0.5. So 0.1, it means it's just very short here over the U, but you have a very long V. So your line will be going towards the northern region. So you get a line like this. Okay, but if you have, let's say, U 0.5, but V going downward, so you get a arrow heading towards south. So the same thing for this one. So positive, when you have something positive for U, it means it's going to the eastward. Okay, just like your line number. Okay, when you write on line number, right? If you go from left to right, the number increase. But if you go right to left, number decrease. So when you write something down to up, positive, increase. Up to down become negative. So this is how you draw the vector. Okay. So obviously, usually computer will draw for you lah. But let's say if I ask you to calculate the wind speed, you know this is the formula you should use. Okay. For example, wind rows. Usually, I don't know. Maybe this is very familiar to you all. Basically, it shows where the winds come from and the strong the wind coming from that direction. Okay, so another example is this arrow. So probably you are familiar with this. You've already drawn this with Palmaply. So basically this shows you where the wind blowing. So you can see from here there's a one particular wind pattern here. So it tells you something like this lah. So if you don't see this arrow, you don't know, say some circular motion here. Of course, you can also draw a streamline. Which basically show you where is the circular motion, where is the straight. I mean the motion that the wind goes straight, or even as a current with ocean current. Of course, you have wind bulk, or even you have this weather plot. If you usually the direction at a certain point. For example, if you deploy CTD, you're trying to measure the current speed and the direction. So this is what you use, vector plot. And another is called progressive vector. So basically, we try to chart where a certain point move in the space. You see, at a certain time, the point is here. At a certain time, the point is here. So this is called progressive vector diagram. Okay? So important if you try to study something known as Madden-Julian oscillation, MJO. I think you already studied this in your methodological class. So when they draw something like this, they draw a progressive vector diagram. So basically how to read, you see from here, start, okay, starting point. So you follow the next point, the date. You look at the date to follow to the next point. So eventually you can see how something moves in the space. Okay. And this is example, you draw a 3D, or you combine different plot together. You have a surface, you have a section combined with vectors. Examples. All right. So we almost until the end. So next, we talk about graphic storage. Okay, this is very important. So when you store graphic, right, there are two formats you can use when you store your graphic. First is what we call bitmap or raster. Raster here means you keep something in pixels. Are you familiar with pixel? So you can imagine like your phone having 20 megapixel. So you have a phone 8 megapixel. So when you zoom your photo, you can see boxes. You can see peta. So that one is called pixel. Another format is vector. So vector format, unless you do a design, probably you are not that familiar with. So for vector, right? So when you see a line, let's say if you see this line on my slide, right? If raster, right? Raster will store everything. I mean, in these query boxes. But for vector, it will store this line in formula. Example, y equal to 2x plus 3. Example, 2x plus 3. So when you the usefulness of storing something in a vector is you can scale it. Yeah, let's talk about it later. So okay, for bitmap, so the format that you usually use is JPEG, GIF or GIF, PNG, BMP, TIFF, etc. Okay, so I think you're very familiar. PNG, JPEG, especially JPG, or TIFF. So these formats are actually bitmap, meaning storing information in pixel. For vector, usually EPS, SVG, or PDF. Surprise, surprise, right? PDF is actually vector. So if possible, you always want to store graphic in vector. Okay, the reason is because if you store something in vector, your graphic in vector, you can edit it later. Let's say you make a mistake, you make a spelling mistake in your figure. So you can easily just edit it with the correct software. Okay, for example, you can use an Adobe Reader for PDF, or Adobe Illustrator for EPS, or even Inkscape, or even some software used by Mac person. So if you have vector graphic, you can fix some small mistake. And it's scalable. So let's say if you want to print your figure at let's say a 10-meter banner. So if you store something in pixel, in bitmap, you try to print it, it will look very blurry. But if you have vector, if you print something on a 10-meter banner, it will still look very sharp. Okay, so that's why if possible, when we draw our figure, you always want to save it in vector format. Okay, and you have to remember, you want to convert vector to bitmap. Yes, you can. Then you can save vector graphic to bitmap, meaning save it as JPG. But if you already converted your figure to bitmap or raster, you want to save it back to vector, it is not possible. Okay, so let's say if you have PNG, you open the PNG in, let's say, Illustrator, Adobe Illustrator, and you save it as EPS. That will not make your graphic as it will not make your graphic become vector. Okay, so we have to remember vector to bitmap okay, but bitmap to vector not okay. Okay, and always remember when you try to plot figure, try to have fun. Okay, if you don't have fun, you don't enjoy doing what you are doing, I mean, you cannot make a good figure. Okay, so be creative and have fun, and always remember, aside of the standard way we produce visualization like maps, graph, you can be creative when you want to design, visualize your data. Be creative. Think of a way that you can easily convey your message to other. So let's say example from here at the below. So I have a table. Yeah. So I want to show, okay, we have many value. So 20 times 18, the table. Right? You can see this value. So you can show this to your reader, but most likely people will just skip the table because it's boring. Yeah. I don't know what am I supposed to expect from this table. Right? So rather than showing value like this, you can paint a table. Yeah, I mean in Excel, there's a conditional formatting where you can paint the value like this one. Yeah, so blue color signifies, let's say, small value. Red color signifies large value. By the way, these two tables actually not related, but I just show you example how we can paint the table. Yeah? So make it have color. So when we look at this, you know, okay, this area have very large value. So this area have small value. So for sub-region number 9, experiment 01, it has a small value. Yeah, but for sub-region 08, experiment number 4, it has a higher value. Right? So at an instance, it makes your table readable, easily readable. Okay, rather than it just show value. Okay, so these are be creative and have fun, like I said. So another more complex figure is like this. Yeah, so this is like a fan-shaped diagram. So what this diagram is actually is summarize 3 information into one: the standard deviation, correlation coefficient, and root mean square error. Okay, it can summarize everything into one diagram. The black dot, black circle dot is a reference, and the colorful thing is your experiment. Yeah, so if you have diagram like this, it tells you basically if the dot is closer, the colorful thing is closer to the black dot, it is good, it's performing good. Yeah, so straight away you look at this diagram, you can tell which experiment performed the best, right? So rather than you have to show 3 different diagrams like standard deviation, correlation, and root mean square error. So difficult, so tedious. Yeah, but you just make it like this. Okay, summarize 3 information into one figure. Sorry. Right. So the next one is what we call a bivariate plot. This is usually for people who work with concentration chemistry. So we want to know in which direction actually the concentration coming from and how much. So you can plot something like this. This is something like a Rose diagram. Wind Rose diagram. So what it did is it summarized concentration, wind direction, and wind speed. Okay, so this gives you information. Okay, usually high concentration is coming from the east. Yeah, and low concentration usually coming from this west to south region, southwest region. Yeah, so this information, I mean, this diagram gives us information like this. So imagine rather than you have to show concentration, wind speed, wind direction, 3 different information you show separately, so it's difficult to interpret. But if you have figure like this, straight away you can tell already high concentration coming from the east side when the wind is not as strong. Okay, so ending remarks. Yeah, so the advancement of data acquisition will lead to explosive increase in scientific data. So there are so many ways we collect our data. So there are so many data for science, for scientific study. Okay, and with the advancement of computer, there are so many ways we can look into our data. Therefore, it can, I mean, create opportunity in terms of research for us. Yeah. In the past, people cannot think of vaccine, but now we can. Why? Because of the advancement of data collection, advancement of computer. the way people can draw a diagram. So although almost obsolete, hand-drawn figure is still there. Sometimes we still need to hand-drawn our figure like graph, horizontal map, like I told you about this weather forecaster, where they have to draw the figure so that they can tell what actually the flow of the weather looks like. Okay, and there are so many different way you can plot your figure. So many software out there. You can choose any one you like. Yeah, for example, in your class, I will show you again multiply because that is the easiest to draw for. So that is the easiest tool to use when you want to work with earth sciences data. But there are some other software that you might like. For example, ArcGIS, QGIS, Ocean Data View. Yeah, there are so many different packages you like. So you just choose the one you like the most. Okay, and sometimes you can just straight away use online too. Okay, you don't really need to draw it on your by yourself. You can use online too. You just click, it give you the diagram. Yeah, but obviously we want to avoid that. And of course, remember a good graphic, it has to be clear, precise, and informative. Yeah, so and also need clear, neat, tidy. Yeah, and of course, don't forget the scale, label, a title. And if you are using graphic from other people, you have to give credit. Okay. And lastly, be creative and fun. Okay. So this ends our class today. Let me stop the recording.